In our last lecture video, we talked about what alpha is and how we can use it, right? Our threshold level. And for the specific problem that we've been working with, we found that our p-value was less than alpha, which gave us enough evidence to reject our null and to support our alternative, that the likelihood of rolling an odd number is greater than 50%. We had enough evidence to support that. You found me guilty. You sent me to jail. However, did you definitely make the right decision? I don't know. Maybe. Right? So just because you support HA doesn't mean it's necessarily true. There is a chance by you finding me guilty and sending me to jail for giving you that fixed dice, there's a chance you could be making a mistake. What alpha also represents is something called our error rate. Specifically, alpha represents a type 1 error rate. There is a chance that you can be making a mistake by having enough evidence to support HA. Maybe I gave you a fair dice and you just got a wacky sample when rolling it 2,500 times. There's a chance that could happen. It's possible for sure. It's very important to denote, regardless if we support HA or not, there's always a chance we're making a mistake. However, there's two different types of mistakes that we can make. One which is represented by alpha, which we call a type 1 error or a type 1 error rate. The other which is represented by beta, which is called a type 2 error rate. Let's see an example of a type 1 and a type 2 error in this situation. In reality, something is true and something is false. Think about the real world as our unknown, right? If we knew reality, well, we wouldn't be doing hypothesis tests in the first place. We wouldn't be having a criminal trial in the first place if we knew something to be a fact. Think of HO being true as like a person being innocent. Imagine in reality, they really are innocent. HO being false, think of them as being guilty in reality. If we knew reality, there'd be no trial. We would know the answer. But these are unknown to us. What we have is our sample world. This is what is known. And at the end of our trial, we're going to make a decision. Fail to reject HO, which is represented by saying someone is not guilty. Or we reject HO, we find them guilty. So there's 4 different possible scenarios. Before we start a criminal trial, there's 4 different outcomes. The first outcome is the person is in actuality, in the real world, they're innocent. And we find them not guilty. That would be the correct decision. Not guilty, and they're actually innocent. However, they could actually be innocent, but we, for whatever reason, found enough evidence to find them guilty. This is what a type 1 error is. A type 1 error is when you reject the null hypothesis. You find them guilty, but in actuality, they're innocent. In actuality, it's true. That would be a bad decision. A type 2 error would be if someone now is actually guilty. They committed the crime, yet you find them not guilty. That would be a type 2 error, which we denote as beta. The last scenario that could happen is they are actually guilty and we find them guilty. So before a criminal trial starts, these are the 4 different possible outcomes that can occur. Once you make your decision, right? For instance, if we find someone guilty, then our only 2 possible scenarios would be this box right here. Right? If we find them guilty, the only scenarios are we made the correct decision or we made a type 1 error. If we find them not guilty, the only possible scenarios then are we made the correct decision or we made a type 2 error. We'll never necessarily know if we made the right decision. That's the point of statistics. I mean, we're trying to estimate something about our population using a sample. We'll never know necessarily if we made the correct decision. All we'll have to go on is certain likelihoods. So we have it in our notes. Let's look at a type 1 and a type 2 error. Now, alpha does not represent the likelihood of making a type 1 error. That's important to keep in our mind. It doesn't represent how likely you are to make it. What it represents is how comfortable are you making a type 1 error. How comfortable are you making that mistake? Beta represents how comfortable are you making a type 2 error. A type 1 error was sending an innocent person to jail. Right? So if I was to write that, innocent person to jail. Right? That's how you can think of type 1. How comfortable are you doing that? Beta, a type 2, represents a guilty person walking free. So the question we need to think about is, what error is more important? Right, for our problem, 3.59% was our p-value, and alpha was 5%. And since our p-value was less than alpha, we found guilty. You sent me to jail. You had enough evidence to say I gave you a fixed dice. Essentially, what that 5% is representing is that you're comfortable sending 5% of innocent people to jail. That's how comfortable are you making a type 1 error. You're okay with that happening 5% of the time. You may say to yourself, though, hey, I don't want to send 5% of innocent people to jail. I don't want to make that mistake too often. So what do? Let's make our alpha level smaller. 0.000000001%. I don't want to send pretty much any innocent person to jail. Now our p-value is bigger than alpha. And we find me not guilty. Now I'm walking free. I'm not going to jail. However, you could be letting a guilty person walk free. If you make your alpha level too small, no one's ever going to go to jail. You're never going to support really the alternative hypothesis. And you're going to be letting guilty people walk free very often. So there's that balance, right? You don't want your alpha to be so big that you're sending a bunch of innocent people to jail. You also don't want your alpha to be so small that you're not making any meaningful conclusions and you're letting a type 2 error happen often. So there's this balance between how small we should make our alpha, how big we should make our alpha. And typically, an alpha of 5% can be that happy medium. Well, you're not going to be making a type 1 too often necessarily. You're not going to be making a type 2 often. It's a nice kind of happy medium between these two error rates, alpha and beta, type 1 and type 2. To recap everything, we found hypotheses for step 1. Step 2, we found a test statistic. Step 3, we found our p-value from that test statistic. And step 4, we compare our p-value versus alpha. Keeping in mind what alpha represents as a type 1 error and as a threshold. Primarily in this class, we're only going to be interested in thinking about alpha as a likelihood. We're not going to be interested in representing our type 2 error rate or comfortability level. We're pretty much going to just focus on alpha for this class.